I think you can do exercise 1, top half on your own. So read the directions and do that now. I'll call somebody up to the board. Who wants to come up and connect the ratios? Angelina, come on up. That's one. Why don't you do the other one too? All right. Ella, come up and do the second one. It's meant to be. Yeah, and 1 to 2 is equivalent to 5 to 10. Did you get both? All right, here's my question for you. Down in elementary school, have you done reducing fractions?
Yes. Yes. Yes.
Sometimes they say reduce, find the simplest form.
Yes.
Reduce the fraction. Okay. Another way that you might see ratios that you're going to actually be seeing more and more is the ratio 1 to 2 can also be expressed this way. It looks like a fraction, but when we say it the same way as we say the ratio 1 to 2. Okay, we don't say 1/2 unless we're in the fraction. If we mean a fraction, we don't mean 1/2. We mean the ratio of 1 to 2. What would this be? How would you say this? Well, don't say it as a fraction. Still say it as a ratio. 5 to 10. Elo, how would you say that? Jen, how would you say that? Okay, it's just another way that you're going to start seeing ratios. As long as we're in the ratios unit, don't say them as fractions. It's not 12 32nds or 6/16, 6 to 16, 12 to 32. Okay, ready? 1 to 2. If this were a fraction, can you reduce it any further? No. We say the value of the ratio is 1 to 2. Original ratio is 1 to 2, and its value is 1 to 2. What about 5 to 10? Is there a number that goes into both 5 and 10? Can we reduce it? Yes. Aiden. Yes. What number goes into both 5 and 10? 5. Ready? What's 5 divided by 5?
0.
Not an uncommon mistake, by the way. I've seen that. Everybody wants to do any number divided by itself is always 1. It's not 0. 5 divided by 5 is 1. What's 10 divided by 5? Ready? The given ratio, 5 to 10, the value of its ratio is 1 to 2. That's why we were able to connect it like we did up here. Because look, remember we did this? The reason why a ratio is equivalent to another ratio is because the values are equal. Both 1 to 2 and 5 to 10 have equal values, 1 to 2. That's the value of the ratio. Let's do it for 6 to 16. What number goes into both 6 and 16? John? 6 will go into 6, but 6 can't go into 16. It's another even number that's smaller if you can come up with it. Think smaller, even number. All right. Julian? Yes, 2 will work. 6 divided by 2, Jules.
3. 8.
Remember that 3 to 8. What about 12 to 32? Is there a number that goes into both? Franco?
4.
Correct. Ready? What's 12 divided by 4?
3.
32 divided by 4.
8.
Equivalent ratios have equal values. 3 to 8, 3 to 8. And that's why we're able to connect those two. Yes,
So pretty much just simplifying?
that's what it is. That's what it is. And let me tell you, this lesson 8, it's short and sweet and reasonably easy, but it is hugely important for you to understand this to do all the remaining lessons in Module 1. We are going to revisit this idea of value of ratio constantly as we build upon our knowledge of ratios. So much so that when you do next week's review sheet, the first 10 questions, the weekly review sheet that you do that's due on Thursday or due on Friday, the first 10 questions, all I'm going to ask you to do is find the value of the ratio. Find the value, reduce the fraction, find the value, and we're going to practice that in our game today as well. Because it's got to come quick to you and it's got to come routinely for you. And we'll build upon it. All right, let's go to the next page. Read exercise 2 quietly to yourself, and then we'll come back to the recording. All right, what's the given ratio? Go ahead, Sal. I want you to write it both ways, in colon form and in what we call A over B form, just like that, because I kind of want you to see it, that it can also look like a fraction that might help you to reduce it. Is there a number that goes into both 4 and 14 equally? Antonio?
2.
2 will go into both. And when you do that, you get a value of
2 to 7.
2 to 7 is the value of that ratio, 4 to 14. For C and D, let's not make it any more difficult than it needs to be. Biking to running, they reverse the label. Original ratio now becomes 14 to 4, which we can also express A over B, and therefore its value, okay, no? 2 goes into both, okay, and that's going to create what value of the ratio? 7 to 2. Good. Now let's see how we can use value of the ratio to find equivalent ratios, or see if equivalent ratios are correct. Read E quietly to yourself, and then we'll come back here. All right, going back to parts A through D, what was the value of the ratio? Do you have a question?
What? No.
Okay, well,
No, I had one.
okay, I'll take it.
No, I don't.
Okay. What's the value of the ratio? What are we doing? Running to cycling, right? What was the value of that ratio? Joel? That's the new ratio. What was the value of the ratio? Look back at part B, 2 to 7. They want to know, using the value, whether this ratio is possible or not. What they're in essence asking is 80 to 280 equivalent to its value? Liam, what say you? What'd you write? According to the definition of equivalent ratios, we take the value, and if we can multiply both sides by the same number to get the new ratio, then it is equivalent. So in this case, 2 times 40 is 80, it works. 7 times 40 is 280, it works. So yes, this is a possibility for his training routine. Okay, flip the page, everybody do F. Possible or not? How many say yes? How many say no? Let's take a look. Original value 2 to 7, right? The new ratio that we're trying to evaluate whether it's possible or not is 4 to 7. Two times what makes 4? it would have to work for both sides. 7 times 2 is not 7. 7 times 1 is 7, right? Therefore, this is not possible. It's not equivalent. And that's all there really is to lesson 8. But I want to practice it. I want it to become routine. So we're going to play a little game. What time does class end? Oh, really? All right. We got time for 4 questions. The last one is worth 2 tickets. Let me stop this. Five to 15. What is the value of the ratio? I don't have time to pass around the frog because we're running out of time. Tristan, what do you say?
1 to 3.
Now, ready? What's the constant?
Times 5.
It's got to work for both sides. It does. He is good to go.
Yeah, baby. Yeah.
Yeah, I like that one.
Okay, number 2.
Oh, it's from right back to my desk.
Value of ratio. And if you're still stuck on how to do it, say to yourself, what number goes into both? Reduce it. Gabs, what's our constant?
4.
She's good.
Yeah, baby. Yeah.
It's recording again. Someone get it wrong. It's recording again. No. It's recording. Someone get it wrong. Someone get it wrong. It's recording again.
Here comes a little curveball for you. You ready?
I'll second. No, I'm just gonna pick a random.
Noah.
Noah. Sacrifice.
It's an important one, actually.
I want to hear the like the one to get it wrong.
Kristen. It is 5 to 9. Is there a number that goes into both 5 and 9?
No.
They're both prime numbers. Therefore, the ratio of 5 to 9, its value is 5 to 9. She is good. Come up and get.
Yeah, baby. Yeah.
All right, last one's worth 2 tickets.
Somebody has that already. No, we can't risk it now. John, you're failed. We can't sacrifice now.
Remember what I told you. If there's not a number that goes into both, its ratio and its value are the same. Value of the ratio.
And that's the value.
There is a number that goes into both. That's what makes it worth 2 tickets.
I know what it is. It's the answer.
Now.
I know what it is.
We should give her a ticket for sacrifice. Yeah,
Go for it. What do you think?
47.
Not 4 to 7.
I know what it is. It's whatever the answer is. I got
Somebody
it.
go figure it out tonight. I'll see you Monday.